Hi everyone, in this video I want to show you a code to implement the RSA encryption algorithm. Now this algorithm is widely used in the encryption of sent messages. Now to explain the main idea, okay, so let me use this. Okay, so now you have a source which is like the sender, the one with the data, and you wanted to transfer it to a receiver. However, you want to protect your message and no one else can uh, understand what is in this message. So what you do is that you use an encryption algorithm. Now, the one implemented here is a very widely used one. It's a very good one, which depends basically on the idea of having two keys. One is a private key and another is a public key. So, as the name suggests, the private key is kept in the privately in the receiver, while the public key can be known to anyone in the reception area. Okay, the area with which you can receive the data. So what happens is that the receiver, the one with the which you intend to send to, generates these keys. Okay, so this keys actually comes from the receiver, not the sender. And the receiver keeps the private key to himself, okay, no one else knows it, and sends away in the air the public key. And this public key is used by the sender, okay, and actually any source that can send to this receiver use this public key, okay, to encrypt the message using the RSA algorithm, and only the receiver with this private key can decrypt this message. Now, if a third element, let's say another receiver or a hacker, has the data, the encrypted data or the message, and also has the public key, he still cannot be able to decrypt the message and get the data. Only the receiver with the private key can get it. Now, this method depends on generating large prime numbers. So the receiver does this process and generates a random large prime number. It has to be a random and it has to be a large prime number. Now in the implemented code here, you have a function, here you see it, and this function is able to generate this random and large prime numbers. Actually also very fast and generates a good and large in quantity, in a value of the prime number. Okay, because when you use a prime number which is like low in value, like 3 or 5 or 7, this can be easily hacked. But as the prime number gets large, you get a well protected encryption. That's why this function generates a number which is high in value, okay, and still a prime number. Now you can see at the end the time this code used to actually encrypt and decrypt the message, okay, and you can see that it is faster than other methods. Okay, so let's try this out. Now what you do as an input is a text file with the message you want to send. So I have here the so this is an example, okay, text. Here is another one, okay, so it's a hello there, and we're gonna use them as an input. So let's try this out. Okay, so here you go. What you have here is an encrypted message. This is the message that is generated, and you can see the numbers here. It's quite large. You can use this message now, which is an encrypted one, and you can send it safely. Okay, and you have generated this using the public key. Now, what happens is that the receiver uses the private key to decrypt this message, and here you can see the original text over here, and here is the time for calculation, which is like very fast. Okay, so let's try the other example. Okay, here you go, and it says hello there. And you can see as the message gets shorter, you get a smaller time. Of course, as you get larger and larger text or a message, you get more time. Okay, you will find the code in the description, and I hope you subscribe to my channel, and thank you for watching.